Hello, wonderful pre-calc accelerated students. Today we are going to do a quick little review of right triangle trigonometry. This is something that you learned when you were in a geometry class. You can see Mr. Covey's doing some review too, looking back at his math book. And we can see that we have a right triangle. I know it's a right triangle because it has this right angle in the corner. And you might have heard this little memory device, SOHCAHTOA. Some people write that just in regular letters, left to right. I like to write it like this, and it's to remind me that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, right? That's what this is saying. And we need to remember that there are different kinds of labels that we can do in a right triangle. For instance, the side that is the hypotenuse is this side labeled lowercase t in my picture. And the hypotenuse is the side that is not touching the right angle. And it doesn't matter which direction you look at the triangle in or from what position, this is always the hypotenuse. So I think the hypotenuse is something kind of like north. It doesn't matter what direction you're facing, north is where north is, right? It doesn't matter. Now the other two labels are more like right and left. You know how you and your friend, if you're facing each other and you hold up your right hand, they would be like looking at it as being on their left. Okay, like right means left and left means right, depending on which way you're facing. So the other two labels are more like that. So if I'm looking at angle R, like I was for all of this, okay, angle R has this side, which is opposite angle R, but this side would be called adjacent. The hypotenuse is the hypotenuse. The hypotenuse can't be either of these other labels, okay? So relative to angle R, those are opposite and adjacent. But if I were looking at angle S, the opposite and adjacent would flip, just like I was talking about the right and the left with you and your friend, okay? So opposite and adjacent are relativistic directions, and they're always relative to whatever angle is mentioned right here. Okay, I'd also like to mention something that just gets under my skin, and that is that this is an abbreviation. It's an abbreviation for the word sine. We do not read that sin. It is an abbreviation, and we read the full word when we say it out loud. This is an abbreviation for cosine. Again, we do not say cos. That sounds just really uneducated, you know what I mean? And then this is an abbreviation for the word tangent. We read it by saying the word tangent. We save ourselves a little time by writing it shorter. And now you see how much time I took just explaining that to you? That tells you how much it bothers me. Okay, let's look here, and here's Mrs. Fry, and she's pointing out that all of these questions are relative to angle D, so pay attention to the D. And what I'd like you to do with this triangle is tell me the sine, cosine, and tangent of angle D. Please pause the video and come back to check your answers. So in parentheses, I put how you should think about each one of these, right? You're thinking opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. The red is what you actually should have as your answer. I would caution you about writing fraction bars that are slanty. In my experience as a math teacher, that causes some problems sometimes. So just try to write horizontal fraction bars. All right, the next four says state the trig ratio that corresponds to each value and to the angle given. So in number 7, for instance, I want to look at angle G, and I want to know what 9 over 14 is. Well, relative to angle G, this side is opposite. The 41 is the hypotenuse. So opposite over hypotenuse, that is sine. Okay, the other three questions all are referring to angle H, and they are for you to try by yourself. Come back when you're done. All right, I hope you got these. Right? There were 3 questions about angle H, so we asked you about every one of the 3 trig functions we know so far. All right, so this one. Now this maybe we're going to review questions kind of like this within our class, but you actually did learn this in geometry, so I thought we might as well do a couple. So in these problems, you're told an angle and you're told a length, like sine of an angle is opposite over adjacent. So we're solving for the opposite side of the triangle. You could write these as proportions by putting a 1 underneath the thing that does not look like a fraction, and then you could just cross multiply. So for instance, A would equal 15 times sine of 20 degrees. B would equal 30 times the cosine of 37 degrees. C would equal 5 times the tangent of 64 degrees, and this one's a little different. D times the sine of 32 degrees would equal 12. Now this one's different because I didn't automatically get the variable by itself, so I need to actually make that happen by doing 12 divided by sine of 32. So now we need a calculator. So if your calculator is somewhere else, go get it. Go get it, you need it. Okay, so here we are with our calculator. We're going to go into the mode key. And this thing that is just a few lines down, your calculator might currently be on radian. We want to set it to degree. This is going to be a very, very big deal because sometimes in this class we'll want radians and sometimes we'll want degrees. And so this mode key that is now red on my screen is kind of a huge deal. Just like you're a huge deal too. But so it's the mode key. Once we're in degree mode, then we can do the questions we were just on. Like we had 15 times the sine, and sine is right there, look at my screen, it's red, sine of 20. 20 is understood to be in degrees because I am in degree mode. If I were in a different mode, it would think that meant 20 radians. You say, what is a radian? I say, keep coming to class. We're going to talk about that. Okay, so my answer there is 5.130. I would like you to be in the habit of rounding to 3 decimal places because if you take AP Calculus next year, which I sincerely hope you do, that's going to be the rule on your AP test. So you might as well get used to it now. So A is approximately 5.130. I'd like you to try the other 3 calculator tasks here and come back and check your work in just a minute. Okay, so the values in red are what you should have gotten literally by just typing correctly into your calculator. Please bear in mind that the sine and the cosine and the tangent keys are those right there that I just made red on the screen, right in the middle here, okay? Remember that you want to be in degree mode, okay, for these problems, not for all time. All right, last 2 questions. This is going to turn into the kind of problem we just did, but this one starts with a picture, so it combines the 2 skills that we've kind of looked at together. So this question has a 60-degree angle marked. You are going to use the not 90-degree angle. I should actually say that. 90 degrees is also marked here, but right triangle trig is based on acute angles, which means between 0 and 90 degrees. So you don't use the 90-degree angle, okay? The 60, I'm going to look at that A and say, aha, you are opposite the 60-degree. And the 12, that's the hypotenuse. Doesn't even touch that 90-degree angle. So if I have opposite and hypotenuse, I want to use the sine ratio. The sine of 60 degrees is A over 12. And then I want to solve it like the questions I had on the last slide. I cross multiply. And then I'm going to multiply those things together on my calculator. And I get 10.392. Since I rounded, I use wavy equals to show approximation. Okay, I'd like you to try the other question on this page by yourself, come back and check, and you are done. Alrighty, Roo, you should have used tangent, opposite over adjacent. The hypotenuse is not involved in this question, so that's tangent. So 40 times tangent of 12 should give you about 8.502. Rock and roll. Happy days. See you in class.